Hello everyone. In this given problem, I'm going to show you how to calculate the energy gain by a substance given that this substance not only has its temperature increased but also a change of state occurs. Now the point to note here is that the change of state in any given problem may not be so obvious. So let's discuss this specific problem so that I'm able to bring my point across more accurately. You are supposed to calculate the energy required to convert 2 kg of ice at minus 12 degrees Celsius to steam at 100 degrees Celsius. And you're given that specific latent heat of vaporization of water is 2.26 million joules per kilogram. Specific latent heat of fusion of ice is 336,000 joules per kilogram. Specific capacity of water is 4,200 joules per kilogram per Kelvin, and specific capacity of ice is 2,100 joules per kg per Kelvin. What you have been given is ice at minus 12 degrees Celsius. So basically, ice is actually water in a solid state, and steam is actually water in a gaseous state. So that means before you even attempt to solve the problem, the implied meaning here is that ice has to melt first and then the water has to boil. So that means there are two changes of state that occurs here without being explicitly stated, and these two change of states occur at 0 degrees Celsius and at 100 degrees Celsius. So 0 degrees Celsius is where the ice melts, and 100 degrees Celsius is where the water boils. Now, even after you figure this thing out, please do not attempt to solve the problem yet. You need to identify the temperature range at which the temperature increases and the specific temperature at which a change of state occurs, and actually what happens to the water, ice, or steam at each point. So far, this is what we know. From minus 12 degrees Celsius to 0 degrees Celsius, the temperature of the ice increases. And then at 0 degrees Celsius, ice melts. Change of state. And from 0 to 100 degrees Celsius, temperature of water increases. And at 100 degrees Celsius, water boils. Change of state. So that's what we know so far. Now, there's a lot of information packed into this one line. And the line is calculate the energy required to convert 2 kg of ice at minus 12 degrees Celsius to steam at 100 degrees Celsius. A lot of data is packed in here. So what we're going to do next is to structure the data so that we can solve this question more easily. It will take time, but this investment is needed so that you can focus on solving it instead of figuring out which number belongs to which part of the equation as you try to solve it, and it can be very confusing. So first things first, let's lay out the data. We know that this question involves only heat gain by ice. So only involves heat gain, I don't have heat supply. Okay, we are not given that info, we are only given heat gain. So first part is ice. This is actually ice. So M1 2 kg, C1 is 2100 joules per kg per Kelvin, and the temperature rises from minus 12 degrees Celsius to 0 degrees Celsius. As mentioned in my earlier video, change in temperature in degrees Celsius equals to change in temperature in Kelvin. So I'm not going to talk about why it's 12 Kelvin. Please refer to the previous video. So this M1 C1 change in theta 1, we are referring to this ice. And then M2 L2, we are referring to the melting ice. So energy needed to melt this ice. So these are the data available. And then M3 C3 theta 3, change in theta 3, this refers to the temperature of water increasing. So I pack all this data here. And finally, M4 and L4, this is where the water boils. This is where it is converted from water to steam. So you can see what I meant by laying out this data is much neater now. Note that although the substance is constant throughout, I could easily just use M to represent all the four masses, but I prefer to label M1, M2, M3, M4 so that it's easier for me to write out the formulae to solve the problem later. So to solve the problem, heat gain equals M1 C1 change in theta 1 plus M2 L2 plus M3 C3 change in theta 3 plus M4 L4. So what I do is I just plug in the values. So you see why I lay out the data first. So that when I have to substitute these values, it's easy for me to pull in the numbers. So the focus is on solving it rather than figuring out which number belongs to which part of the formula. And once I pull the numbers in, I get my total energy needed. And typically in exam conditions, please express it in 3SF. So you can express in 3SF in this way or in this way, standard form. So both are acceptable.